Serverless GraphQL. So take it away, Johannes.
Awesome. Thanks a lot. Yeah, it's great to be here, everybody. I'm actually not here to talk about GraphCool today at all. Rather, in general, how you would build your own GraphQL server and how you, as mostly front-end developers, probably can still use like awesome new technologies like serverless deployment options to you as front-end developers build your own servers. So a couple of questions. So who of you is a front-end developer? OK. Who of you is a backend developer? OK, a couple of people. Who of the backend developers have already built a GraphQL backend? OK, so hopefully there will be a lot more after this talk. So yeah, my name is Johannes Schickling. I'm based in Berlin, moving over to San Francisco this summer. I work at GraphCool, and our goal at GraphCool is sort of to make just server-side development with GraphQL a lot easier. And today I'm not talking about GraphCool, but rather about a new project that we're working on with Prisma. If you want to follow me, you can find me on Twitter or on GitHub. So before we're starting off, I want to give a quick tour through like the last, let's say, 2 decades of how server development has evolved over the time. Give you a quick idea of how a simple GraphQL architecture could look like. Then we go through what a GraphQL server actually looks like, how that works, how you build one, including a small live demo. I'll give you a quick introduction to Prisma, which helps you to build GraphQL servers talking to a database. And afterwards, we'll look into the serverless deployment options, and also including a little demo. So let's start roughly, yeah, let's say 15 years ago, so 10 years ago, where mostly when you wanted to build a backend, in the early days, you needed to think about like, oh, where do you get my own server? Then with like, as the cloud came along and DigitalOcean, it got a lot easier to just spin up a droplet, spin up an EC2 instance, but you still needed to think about the actual notion of like, I have a server, my server has 4 cores, my server has like 4 gigabytes of RAM. Throughout the same time span, building monoliths was typically the default. So you're building things like backends in Ruby on Rails and so on. So, and when we were looking at the API dimension in that time, that typically meant you were delivering directly an HTML rendered website, or maybe in earlier like a SOAP API, but let's not talk about that. So then over the last couple of years, with AWS building more and more tooling and other clouds also coming after that, like more and more container-based technologies came along and managed services. So that meant you were still thinking about servers, but you don't need to SSH into them anymore and install all of that stuff, but you rather have like a managed server. So you have like a managed MySQL database or a managed Kinesis stream or whatever you have. And in the same time span, people have been moving more and more away from building monoliths to more splitting things up horizontally into microservices and also vertically in different layers. And that also means like there is a clear separation between front-end and back-end. This is why we are all here as front-end developers, that we can focus on building React applications, single-page applications, and somebody else can take care of the back-end. And the separation there, the interface was typically a REST API. And nowadays, this is where GraphQL is really becoming the new default of how clients talk to servers. And also how you think about and manage infrastructure has evolved a lot. So we're now at a point of time where we don't, for most things, we don't need to think about the server behind this anymore, but we can leverage serverless infrastructure. And there's also a new way, like a new architecture pattern coming up, which is more based around functions as a small architecture units that you're thinking about. So this maybe gives you a quick overview over the last couple of years, how the infrastructure, the architecture, and API standards have evolved. So the advantages of that, of like the serverless infrastructure, about microservices, and about the GraphQL API, like I cannot dive into all of them, but around serverless infrastructure, it's mostly around that you don't have to worry about the servers at all, and you don't have to maintain them. Typically, serverless is also synonymous with scales automatically, so you don't, S3, for example, is a serverless technology. You don't have to think about, oh, does S3 scale? That just works. And it typically also comes with a pay-as-you-go model, which is a lot more convenient to reason about. Microservice-based architectures are typically, as said, split up vertically and horizontally in layers and components, which on the backend side leads to faster development and typically decouples systems. And GraphQL, where I would like to dive into the most today, gives you just a way more expressive way to query and request data. It provides type-safe tooling. So now that we're more and more also using things like Flow, Reason, TypeScript, we can actually map that directly to the GraphQL API that we get, and we just get better tooling. We need things like auto-completion or error catching in our editor, which is great. And yeah, in general, it just provides a very rich ecosystem of tooling. So let's take a quick look of how a typical GraphQL architecture would look like. And that's actually very similar of how an old REST architecture would look like. So you have your client, you have your server, somewhere fairly central, and the server typically talks to a database. So for a typical GraphQL request cycle, that looks like this. Your client sends a GraphQL query. Hopefully, you've all seen John's talk yesterday about an introduction to GraphQL, and you can follow how that works. But a GraphQL query, you can think about it almost like a JSON object just with the keys that tells the server, hey, this is the data that I want. And the server then sort of fills out the data that you're requesting and sends it back. And today, we basically want to look into how does this GraphQL server actually do it, since that's not that complicated. And I'm pretty sure that most of you here as front-end developers can sort of level up as a full-stack developer if you want to. So we won't dive into GraphQL clients today. This is mostly probably the touch point that you already had with GraphQL on the client. So this, for example, using Apollo client, which is really neat because you can directly tie your data dependencies directly to your React component, for example. But let's talk today about the GraphQL backend. So how do you actually build a GraphQL server? So in general, there are kind of three things that you need to think about. The first thing is the GraphQL schema. So the GraphQL schema is sort of on the paper, the contract that a GraphQL server presents to the world. And this is how the client knows what sort of queries you can make. And the second part is the resolvers. So that's the implementation of the contract that you're making, the implementation of the schema that you're defining. And the third part is sort of the glue around that in your GraphQL server, which is typically like a GraphQL server framework that typically includes a so-called GraphQL engine. The GraphQL engine is basically just, since you're defining through your resolvers a bunch of functions that return data somehow, the GraphQL engine specifies in which order these functions are called, with which arguments. We'll see that in a second. And also, since a GraphQL server on principle is a fairly abstract thing, you also want to tie that to an actual network protocol, to HTTP or to a WebSocket layer. So this is what typically a library takes care of. So let's take a look at the Hello World example of how you would implement a GraphQL server. So as said, you need to specify your GraphQL schema. So here, the root entry point for specifying your schema is always a type called query. So here, this is our Hello World example where in our type query, we're specifying one field called hello, which returns a string and takes also an argument as a name. So now that we've specified the schema, we need to implement that schema using resolvers. Again, resolvers are basically just functions. So here, and also notice that the structure here is very similar. Here we're specifying a type query, and here we're just having this map of types, which maps directly to our type definitions in the schema. And here our function basically just returns the string hello world or hello some name if it was provided. And that's basically all you need to do in terms of implementing a hello world of a GraphQL server. And then you just have this glue around here. So the easiest way to spin up a GraphQL server in Node would be using GraphQL Yoga. Here you basically just provide your type definitions, your resolvers, and that makes it available as a HTTP-based GraphQL server. So let's take a look of how that actually works. So let's see whether the internet is actually working here. So this is simple. So what we do first is install GraphQL Yoga. GraphQL Yoga, as said, is sort of the simplest way of how you can implement a GraphQL server. It uses certain best practices and gives you things like file handling out of the box. But there are many ways how you could implement a GraphQL server. So now we have that installed in our package.json. So let's implement the server. So we are just creating an index.js file. And you have to tell me whether that's actually big enough. And since I'm lazy and won't write all of that manually, I've prepared a little code snippet, but we'll walk through that. Whoops. So this is essentially just the code that we've seen before. Can everybody read it here? Cool. So as said, we're just specifying our schema. We're implementing the resolvers, tying it all together here, and starting our server. So let's actually do that. Let's just run node index.js. Server runs on localhost 4000. And there we go. We have a little GraphQL server. So what you see here is, maybe you've already seen this before. This is called a Graphical Playground. It's sort of a bit more of an advanced version of Graphical. It's just a browser-based IDE for making GraphQL queries to play around with your GraphQL API. So based on the schema, we are getting auto-completion. So just by having specified here type query hello, we get the same schema available here. So we can query hello, we get hello world, or we can say hello SF. Oops. And we get hello SF. So that is as simple as it can get a GraphQL server implementation. So did that make sense to everybody? Awesome. So the next steps I want to walk you through a bit of a more advanced GraphQL server, and mostly of what a GraphQL engine actually would do in terms of invoking your functions at the right time. Since in our example here before, we basically just had one resolver function, but in a more advanced GraphQL server, you typically have like an entire hierarchy of resolver functions, and it's the job of this GraphQL engine to call them in the right time. So let's imagine for this schema here, where we have like a simple blogging application with posts. A post has an author, and a user has also several followers. So for this type of schema, let's imagine the following query comes in. So here we are querying the posts. For every post, we are querying the title, the text, and the author, and for each author, the name and the followers. And if this query now comes in, I think it's really important to understand how a GraphQL server would now, in which order it would call these functions. And this is what I want to walk you through here in a simple example. So let's say this comes in. So we're starting at the root level. So at the root level, first the posts resolver would be called. And note here, like this, I haven't really implemented these resolver functions. This is just that you understand the execution. So first, the post resolver would be called. Once that has returned, we're descending into the next layer, where we're resolving the title, the text, and the author. Here in that layer, note that the title and the text resolver are commented out because you don't really need them, since they just return a scalar field, which would sort of be the identity function. So you can just leave that out, and it will still work when the posts, the post resolver in the query actually returns a value for title and text. So in this level, we're already then returning the author, and in the next level, we're for the author of our user, we're now resolving the name and the followers, and dive one level deeper. And at this point, we've now returned all of the data, step by step returned all of the data that we need. And this GraphQL engine, your GraphQL server, puts all of this data together and puts it into one JSON blob and returns it. So this is on a high level of how like a more complex GraphQL server example looks like in terms of the query execution. But what's actually interesting is how would you actually implement these resolvers? Since this is the hard part, this is where you would spend most of your time building a GraphQL server. So let's take a look at some of these. And I think the most common example what you would do in GraphQL resolvers is either you would wrap an existing API, so you would wrap your existing REST API if your backend doesn't directly provide a GraphQL API, or if you're writing a native GraphQL server, you would be directly querying a database from there. And that's one of the most common scenarios. So let's take a look at how this would look like. So from our previous GraphQL schema example here, we've slightly extended that. We've added for the posts, we added 2 arguments, filter and skip. And also for users, we added another field here called isVerified. And to implement this top-level posts query resolver, this is how a typical implementation could look like. And whoever has here amongst the backend developers has built a GraphQL server or even a REST server, dealing with these sort of SQL queries is fairly scary, and whenever you make a change, this is typically the first thing that breaks. And here, by using GraphQL, we can actually leverage a lot of great tooling that massively simplifies that. So in the same way as like you could use an ORM and like REST and for building REST servers, or also for GraphQL, GraphQL gives us a lot of nicer advantages here. So you can kind of think about this, simplifying this by using a GraphQL ORM. And this is how the syntax would look like here. So you basically, you can omit which fields you're selecting. GraphQL, this is already information that sits inside of your GraphQL query. And you can sort of map, this ORM already maps to the type system of your GraphQL server. So before boring you with too much theory about this, let's actually dive into a little demo. And then we deconstruct that and try to understand of how this works. So then the next couple of minutes will be all about how would you implement a GraphQL server that actually talks to a database. So let's take another look. In this case, we don't start from scratch, but we're using a boilerplate. And we can use this boilerplate by using the GraphQL CLI. So we can just do this react-thon. So this will now prompt us which boilerplate we want to use. So there are a couple of options. In this case, we're just using the Node Basic one, which already has some, let's make this a bit smaller, which already supports a database connection out of the box. So this now installs basically all the dependencies we need, and we start off with a nice little boilerplate that's also very similar to this blogging example before. And through this process, it also now asks us to where we want to set up our database. In this case, I'm choosing my local setup. I'm just running Docker here locally right now. So this will already set up my database, and this is what's using Prisma in the background, which basically makes it a lot simpler to deal with databases when building GraphQL servers. So let's enter this new directory, open it in VS Code. Hopefully that's big enough. And let's dive a bit into the code base here. And just before we left off, basically the CLI here told us go into this directory, and we can start our server with yarn dev, which we'll do in a second. But let's first explore what sort of code is created here. So package.json is fairly simple. We additionally to GraphQL Yoga, we now got this Prisma binding, which is kind of like this GraphQL ORM that we talked about before. And the actually interesting part is now our index.js file here. And also one caveat here is just for the sake of simplicity that everything here is in one file. Obviously, as you're building a more complex server, you would split that up into multiple files, and then there are various best practices that fit to your style of writing a server. So on a high level, this is exactly what we had before. We have our resolvers. Our schema, our type definitions, actually now lives in a separate file, in a schema GraphQL file. So here we now have a type query which returns a feed, which returns drafts, which are both of type post, and we have a couple of mutations how we can actually work with data. So let's take a look at how the resolvers are implemented, since this is the interesting bit. So, and compared to what we've seen before, we actually don't have to write crazy SQL queries here, but we can use this GraphQL ORM-like pattern, which maps directly to our underlying database, which is also specified using GraphQL. So take a look here. So here we can query the underlying database by posts or a specific post, or we can create posts. And this works because in using Prisma, we can specify a so-called data model, which is basically the schema that your database is set up with, also using GraphQL. So here we are specifying the structure of our database simply using GraphQL. We would say we have a type post, which would translate to a table post in your MySQL database or in Postgres, whatever database you actually want to use under the hood. And you specify your fields, which would map to a column. And based on that, you get a ready-to-use database that you can query using this syntax. So here we implement all of our resolvers. We can implement a bit of business logic around that if we would want to. So here, for example, when we create a draft, we always set is published to false. So we implement all of our resolvers. We tie it together. And here in the context, we're specifying the connection to our actual database. So let's give this a try. So we run yarn dev. This should be starting our server. And here we should now be able to query our feed where we can query the ID, title, text, and we get back this data. So that's basically how simple it is to implement a GraphQL server talking to a database. And in the following slides, I basically want to explain a bit more of like how that works under the hood, and then show you how you would take this and deploy it into production using serverless technologies. So let's go back into the slides. So what we've been using here under the hood is called Prisma. Prisma is this connection between your GraphQL server and the database that makes it a lot simpler to implement your GraphQL server. So, and that works by Prisma actually turning your database into a GraphQL API. So that's a bit tricky here to understand, since this GraphQL API that Prisma creates for your database, you wouldn't use that directly from the front end. But instead, in the same way as you have for React, and you have React components that are composed out of other React components, GraphQL actually allows you to create a GraphQL server by composing other GraphQL APIs. And this is exactly what we're doing here. So in fact, we have, compared to our original GraphQL architecture here, we have it extended like this, where we have two GraphQL APIs in a layered architecture. And the second part, where we're using Prisma, is sort of your data abstraction. So going back to what is Prisma? Prisma, as a technical term, would be a GraphQL database proxy that takes your database and creates a CRUD-like GraphQL API for your database. So it leverages GraphQL in two ways. So one, that you can use GraphQL to actually query your database, but also, as we've seen before, it actually uses GraphQL that you can model your database, that you can model how your database tables looks like, or that you can map to an existing one using GraphQL, which is a very nice mental model. And Prisma, as a CLI, then helps you with common database workflows, like backups, migrations, and so on. So there are two parts, or three parts it's worth diving into. So first, the data model. Again, this is the part where you specify in GraphQL SDL how your database schema, your database model would look like. So here we have a type user, a type post, that would map to a user table in your database or to a post table. And based on that, Prisma generates a GraphQL API that gives you a very intuitive API. It gives you flexible filtering capabilities, like even across relations, gives you an aggregation API. And what's very neat about this, so whoever has used RethinkDB in the past, like one of the core features about RethinkDB was that you basically got real-time characteristics around your database. With Prisma and GraphQL, we can basically give you the same real-time characteristics for any kind of database. So GraphQL, for example, supports a feature that's called subscriptions. Over the next couple of months, there will probably be a new feature called live queries, which gives you real-time capabilities around your API. And with Prisma, basically, this is directly supported for your database, which is a really exciting feature. And this glue between your GraphQL server and your database, this would be what we've before called a GraphQL ORM. It's actually called a GraphQL Binding. And this GraphQL Binding, this is a technology that uses schema stitching under the hood. Schema stitching, if you're interested in that, that's sort of like like how this works under the hood, how you can combine a GraphQL API into a new GraphQL API. And that on its own actually solves a ton of the inefficiencies of typical ORMs, where you have performance problems when you hit scale, or where you have certain expressiveness problems when you hit edge cases where you cannot express a certain data dependency. So one very interesting bonus here is if you're building your GraphQL server in a typed language like like TypeScript or Reason or Go or any kind of typed language, you can actually now map the type system from your GraphQL API into your programming language, which, yeah, that could be an entire talk on its own, but it's a very interesting feature. If you do that, then like one of the nice characteristics you get is the same kind of auto-completion that we've seen before in the playground. You now get, based on your GraphQL API, in your editor. That also means you catch like typos and so on. So let's use the last couple of minutes for the serverless deployment options. The most important thing about, or the most common misconception about serverless is that there are no servers, which is not true at all. So the most important thing to understand about serverless is that you don't have to think about servers. Some other smart people take care of that there are servers indeed. That's typically AWS or bigger cloud providers. And you can just do that with economies of scale. So the good thing is you don't have to think about servers. There are still servers, but you don't have to think about them. So, and some of the benefits here are, like, one, you don't have to think about how many servers should I deploy in my Kubernetes cluster, or like you don't need to maintain them. You don't need to think, oh, do I need to install this new Ubuntu version? You can just focus on the application. Given how good of a job AWS does, it's sort of infinitely scalable, and comes typically with a pay-as-you-go model. That means if you don't send any requests, you don't pay any money. And similar what we have with Netlify was like that for every commit, we get a new endpoint, a new deployment. We can actually do the same thing now with servers, which is really interesting. There are different, serverless doesn't just mean like how you can deploy your Express app or however you would deploy your node server, but there are multiple serverless categories. So as said, S3 is, for example, a serverless offering, or serverless Aurora is a serverless database offering. But in our talk here, we're focusing on the compute angle, which, for example, is AWS Lambda. To deploy your application to a serverless environment, there are multiple tools available. There is one by TJ Holowiczak, who is the creator of Express. It's called Apex Up. There is the serverless framework. There is Now. Netlify just yesterday launched Netlify Functions, which is really awesome. And AWS also provides a tool how you can deploy functions. I originally wanted to use Up, but I hit some network upload issues, so that would take 3 more minutes. So since it's a bit quicker, actually, I'm using Now for this live demo. Whoever hasn't used Now here, it's really nice and simple to use. Simply install it via npm, run Now, and your server is up and running. And yeah, so let's take a quick look into the infrastructure that we're now deploying. This is an old slide. We're deploying the GraphQL server using Now. We deploy Prisma to a development cluster in Prisma Cloud, and we're using AWS Aurora under the hood. So let's give this a quick shot. So what we basically do is here in our server before, we need to deploy this to Prisma Cloud. So what we do is here we just say to my demo account Prisma US1, and here to the production stage, and say Prisma deploy. This is what happened with the GraphQL CLI command automatically. So what we'll get here is a new deployment for Prisma. This one we simply put in here where we've before talked to our local setup. So we just put this in here. 1 second. And now just run Now. And in a second, we should hopefully have our production endpoint. Let's see. Take a second. All right. Boom. So, and we should hopefully be online. All right, so here we have online our actual production deployment, which we can query. Cool. So, last couple of slides. Takeaways for you. Hopefully, it's a lot less scary for you as front-end developers how you can build GraphQL APIs. GraphQL APIs are really like the new default of how you would build GraphQL, how you would build servers and APIs in general. Prisma, if you're using a database, Prisma makes that working and connecting to a database a lot easier. And using serverless infrastructure in general to deploy your servers is definitely the way to go. A couple of resources I'd like to share is one, our blog, where you can learn more about how things work behind the scenes, about schema stitching, or how you would deploy this using Up, or just a couple of interesting blog posts about GraphQL. If you're still very new to GraphQL and you want a place where you can get started, you can go to howtographql.com. or subscribe to the GraphQL weekly newsletter. One last thing, we are actually hosting a GraphQL conference in Europe. So if you want an excuse to come out to Berlin in June, this is it. So thanks a lot for your time.